The first thing that we have to do is actually change the function, because if we want to start integrating with respect to r and theta, then we need the equation to be expressed with those variables as well. The most simplest thing is to grab this term here, the square root of x squared plus y squared, and change that into something that can be represented with r. We want to get rid of all the x's, all the y's, and express everything purely in theta and r. The 3 is actually r. If you take this expression here and square root both sides, you'll end up with r on the right hand side and this expression here exactly. So let's substitute this for r. We've already got our function expressed in terms of r, and if you want to integrate something in the polar coordinate system, you integrate with respect to r, then with respect to theta. That's the order that we're going to do. We need to change our limits, express them in terms of r, where r is the distance from the origin. When you look at our graph, it's starting at 0. It can't go past 3 because our limits of integration, r was 3. So we're going to go from 0 to 3. And now we have to think about theta. Well, we know that 0 theta begins here, and this way is positive and this way is negative. We don't really have to worry about theta at all because it's just a full circle. So yeah, let's go ahead and change that. Okay, now we can integrate. As you can see here, we have the function 9 minus r, but we also have an r present here. So we want to expand this so that we can just go ahead and integrate with respect to r without worrying about this r anymore. So this is our function, 9 minus r, and we have an r present. So we actually want our expression to be 9r minus r squared. First, let's integrate with respect to r. The integral of 9r is 9 times r to the power of 2 over 2. And r squared integrated is r to the power of 3 over 3. And then there's a minus sign here. So first we have r squared times 9 over 2. So sub in the 3, 9 times 9 is 81, 81 divided by 2 is 40.5, and we're going to be minusing another term here, and that is r to the 3 subbed in. 3 for r is 27, divided by 3 is 9. So then we have 40.1 minus 9. And then now this is looking nice and neat. It's only in terms of theta now. Theta being not present at the moment, it's theta to the 0. But when we do the integration, we're going to power that up to 1. So it's going to be theta to the power of 1. we're going to substitute 0 and 2 pi into here. 0 is not going to give us anything because theta is a product in here. It's a factor, sorry, in here. So we're just going to sub in the 2 pi and that's going to give us our answer. 31.5 times 2 is 62 pi. We could just leave it, the answer like that. Oh, we did it. We've done something that's quite hard to do in Cartesian coordinates and we changed it to polar coordinates and it was a cinch. And it's a lot easier to just think of the circles in terms of r and theta. So yeah.